Right, so if you want to run a command that will actually help you find the outliers in the whole data set, you just type some detail, then it will bring all the outliers. For example, maybe you're dealing with maybe you are so sure that you are actually having a data set that was actually targeting maybe the youth. Then it happens in maybe in a certain on age, maybe you actually find an age which is maybe around 70. Obviously, you will be able to know, it will show that you have an outlier, because if you talk of the youths, I don't think somebody who is 70 belongs to that category. So if you want to go straight to a particular variable, you can also type sum6, then detail. On this one, you will be able to trace all the outliers related to 6. The other way is also to use a box plot. So you can run a box plot, then the values also be shown. So it means you'll be able to trace all the values maybe that are beyond the whiskers. Then you trace those outliers. All right. The other task was to explain on how we can deal with those outliers. There are two ways. It's either you can drop or you can replace. So if you want to drop, for example, here we are dealing with age, as I already explained. Then you can write drop if years is greater than 70. Yeah, just an example. It means if the value the value, maybe your maximum is 70, it means if the value is greater than that, obviously it will be dropped. So you are so sure, maybe you say I was targeting maybe a maximum of maybe 40 or 45. So you can write drop if years is greater than 45. It means everything that's above will be dropped. Or you can replace. All right, the other task was also to explain on how we can check duplicates. So it means maybe repetition, maybe value. So you actually can check for those duplicates. So it's the same thing. If you want to check for duplicates in the whole data set, you can just type duplicate lists. It means it will bring all the duplicates in a particular data set. Or you can type duplicate report command. Then okay, it means in your data set all the duplicates will appear. Or the other option is still, you can also go to the data editor. Data editor browse. If you click on that icon, it means you have the whole data set. Then you can follow through. Actually, on this one, you can also check for those missing values as well. Then you can also check for the duplicates. And it's recommended at least to go by this one, because sometimes you might drop a value that was actually important or was not supposed to be dropped. So you need to be so sure that you are dropping something that will not tamper with your data. So if you run this command, at least to bring the whole data set, then you can follow through. Maybe they are missing, then you can edit. If it's supposed to be dropped, you can drop it rather than maybe just dropping it through a command. But this one, you can be able to check. So how do we deal with these duplicates? As I said, if you are sure, you can drop. That means after you have thoroughly confirmed that, yeah, this value has been maybe it's appearing twice or more. So you can write duplicate drop. It means it will drop all the duplicates. Duplicates drop. It means all duplicates in the particular data set will be dropped. Or duplicates drop years then comma false. It means it will drop all the duplicates that are existent in years. So there are two ways. It's either you're handling, or maybe you want to make sure that there are no duplicates maybe in years, or you want to make sure that there are no duplicates in whatever the variable you are dealing with. So you can learn that command. Duplicate drop years then comma false. Or you can write duplicate drop. It means you drop all duplicates that are existent in a particular data set. Or as I said, you can go to data editor browser icon, then you can follow through as well. The other task was for us to explain on how we can generate summary statistical. So on this one, maybe we're mainly focusing on the generation of basic matrix commands. So it's like you want to find out what's the mean, maybe what's the standard deviation, what's the mean, like in terms of the like minimum value, or you can run you want to find out the maximum, all those commands. So you can also actually find those, or you can work on those by particularly targeting a particular data set. For example, if you write SU, then it displays all the observations for all numerical values. Or you can write summarize. The other task was for us to explain how you can run regression. So on this one, we are actually trying to find the relationship between the variables. We understand we might have independent variable, we might also have dependent variables. So we are trying to find out what's the relationship between these variables. Are they in direct correlated, or are they inversely correlated? So on this one, we actually have a number of assumptions. It's either the data there can be auto correlation between the data set, or the data set can be in a homocorrelation relationship or heterocorrelation relationship, or there can be normality, that's a bell-shaped one, or there can be linearity. So those are the assumptions that are on this regression. So for example, we're having want to find the relationship between maybe variables like education, sex, and age. For sure, we understand that the education, well, that will be our dependent variable, because it's solely dependent on what actually happens. Sex, or maybe sex can have an impact on education, or as well as age. So you learn, in order to find that relationship, you can write rig, then you come up with the dependent variable education, then those independent variables sex and age. It means on this one, we'll be able to deduce the relationship between these three variables. Then, depending on what comes out, you can interpret to say, what's the relationship here? By looking at the coefficients. For example, if you have a dependent variable, it's indicated as r squared. So, for example, upon running the regression command, and you r squared, you find it to be 0.5. Obviously, here it means 50% of the independent variables affect the output. You can also find the significance, model of significance. On this one, after learning the regression command, then you interpret where there is probability greater than f. So on this section, depending on what comes out there, you can actually explain whether the change is actually significant, more significant, or whatever the result might be. So, for example, in terms of the significance, if you actually have a percentage maybe 5 below, it means significance is there. But you have maybe, and if it's at 1%, it means now the significance is more, or yeah, it's more. The other way, you can also interpret the coefficients. You go where it's written p is greater than slash is slash. So depending on what comes there, you can also explain in terms of in 3 ways. You can have the level, you can have the log level, you can have the log. For example, if a particular unit of data set affects, or maybe to say a unit change in years, maybe is leading to a decrease in education by so margin. So all these are changes, units. It means that's a level unit. But you might have maybe somewhere a percentage, maybe here a unit. So that will take a log stroke or unit. But if they're all percentages, such percentages leading to such percentage, that's a log level. So in a nutshell, this is what we discussed as a group. In case I've missed something, I think if the floor is open, you can contribute. Thank you. Hello.
Hello.
Anything to add?
I think you have forgotten on CSV file and the Excel file opening.
Importing?
No, opening of CSV file and the
The task was
Excel.
to explain on importation, how you can import that file.
Oh, Ndemalongosora. Okay, it's okay.
Bravo, Aguru.
I think it's clear. Then